While searching into the problems I'm having with this spectrum analyzer's display, I came across an owner who has one of these and actually worked at Hewlett Packard back in the day these were being made. And he gave me a few hints, and basically what it's tying down to is what the manual says. It's one of these boards here. It could be any one of them, but behind looks like it's most likely the A3 A6 board, which is the blue board. Has possibly got a problem. Now in the manual it tells you how to test these boards, and it's run into two problems straight away when you're testing the boards on this. Is first of all, you can't get to them, so you need to get a card extender. Now I've searched eBay for them, and you can buy them in a kit form from the States, and I need two 18 by 2, so basically that means a 18 connector edge card, double sided, so that's 36, and I need two of them because some of these cards have got two slots on one card, sort of thing. So I need two of those. That's straight away £50-60. So I've ended up making these pigs ear of a thing. Now this is basically what this is this top is out of an old signal generator, HP signal generator that I bought for spares or repair, and the motherboard was scrapped. So that's the connector of it. So that's the connector I need for the board to go into. That's the mating half, and that mating half is actually only a 15 way. And if you can see in the middle there, I've actually had to glue two boards together to make the half. Unfortunately, it's amazing. I'm sure I've seen these connectors all over the place, and when you want one, you can't find one. So I've ended up making an 18-way connector, and then this is epoxied onto a piece of fiberglass, and then I've basically just connected them straight up, link for link. Now also it's worth bearing in mind, if you've attempted anything like this, you can't see it here because I've glued all over it, but these have wires through them, some of these, and that basically allows you to connect from one side to the other with a wire. So I've drilled the wires out, and then I've soldered these, and these have been insulation tested at 50 volts with a mega, or isolation tested to make sure they're good, buzzed out. So that's my first board, and my second board is in the midst of being constructed. I've finished the first row of wires off. These are just tacked on, and then I'm going to try and encapsulate these and make them look a little bit better. And then obviously I need to do an insulation check on this board. So these are going to be the two boards. They're roughly the same height, and they're a lot cheaper than buying anything off the internet. And of course that you could actually buy these extender boards as a kit, but I don't suppose anyone did. So that should solve the problem of being able to access the boards. The boards will come out. The next step is when it comes to fault finding, it gives you all these ASCII codes, or ASCII codes, binary codes. And basically what it does is it explains what to do. You set it all up, and you use the thing they call a signature analyzer. A signature analyzer pod and probe. Now signature analyzer is basically a meter that grabs the digital data off the line when you send a squirt of signal down it, and it gives you it in binary. And here are all the binary codes you read here, and you need to check the manual to make sure you're doing everything. But with that ability, you can actually basically narrow down to component level, in theory. I haven't done it yet, so we don't know the problem with the board that you're actually working on. And as you can see here, these are all binary codes, and I think the ones in black are sort of fairly straightforward. You just press the reset button on the 7 board, that little white nipple there. You press that, and it squirts the information through, and you grab the information off. Now you can also use a logic analyzer, but speaking to people, they say it's very difficult to decipher what the logic signal will be and then transfer it into a binary. So what you need is a signature analyzer, which is what that is. And luckily I found two of them on eBay, and this one's in really nice condition. It's probably hasn't had an awful lot of use. So basically this is what this is. You've got a little, what they call a pod that plugs in here. It's all inside a leather case. I'll get it all out later on, and I'll once I've connected it all up to boards and hopefully get some testing done. and this basically should give me the information that I need to work out what's wrong with the board, or which board for a start, and start going through and diagnosing what's gone wrong with this bloody thing. Now, as I say, I've got some other boards coming, so that does allow me to sort of just swap boards out and work out what's going wrong. But I would like to actually try and diagnose what part of the board has gone wrong and maybe replace it. Now, I've got a lot of these boards on here are, they've got memory and ROM chips in them, and a lot of them at first you think, oh, they look fairly straightforward, benign chips, and you think, well, that's not going to be hard to change. But when you start typing the numbers into the internet and they say, one available, £30 each, you think, obviously not that readily available, not like the normal sort of logic gates. And I don't know if you can see there in the reflection that those top dollar chips, there's U6 and U4 written on there. So I think that this unit has been worked on before, though I've spoken to people at work who have been there ever since this unit was bought, and they can't remember it ever going out for repair. And if you look on the back of the board, there's no sign of any rework done on it, so a bit confused with that. You notice this darker area on the side here. Now, I'm not sure that's heat, but all the boards on that side, certainly up the top end, have got that sort of slightly discoloured look to them. This is the supply line here, this is an input filter, this is a capacitor I changed, it had a tantalum. The capacitors are absolutely fine, by the way. So I don't know what it is, but I have also noticed, if you can see here, that this is the bottom section. It's got no filter in it, so, and they are supposed to have run with filters in them. So it is possible it's tobacco, stains, it could be anything really. But it doesn't look contaminant, it's non-conductive on the circuit board, so I'm not too worried about that. So that's where we are at the moment. I'm waiting for these boards to turn up. I'm going to start probing around with this, and hopefully with a bit of luck, and if I can get my head around how to work the thing, track it down to component level, and maybe be able to actually find out what's wrong with the thing. Continuing on with the spectrum analyzer, trying to find the fault with this display and with the way it doesn't display graphical correctly, and there's some of the characters looked a bit sort of corrupted. I've built some standoff boards, and you can see that boards are actually in situ now. To buy these boards are very expensive. In the States, there's a chap selling some homemade boards that you basically have to build yourself. And to make two boards, which are, these are 18 by 2, so it's an 18-pin edge connector, double-sided, that's the times 2, and I need 2 of them to run the board. You're talking about £50–60, which is, it's not worth it really, I don't think it. So what I've done is I've built up these riser boards from a couple of boards from an 8662 audio Spectrum, no it's not, frequency generator. They were off the motherboard, and I basically soldered them to some old edge connectors, and I've had to double them up. I've glued them together and then made some extension links up, and this is the result. So we've got some standoffs, we can actually get to the board now. And this device here is called a signature analyzer, and basically what it does is it looks at the data on the chip and gives you the binary number for that particular chip. And the reason why I need this is because HP specified that this is the only way of checking it on when you're starting to check all the logic and stuff like that. Now this is the way, this is the basically how it's all done. You configure the unit in the following chart here. It says ground, test point 5 and test point 8, and then you put a jumper in on test point 3 to test point 6, which that enables the I think that enables the system, the check ROM, to allow you to put the display up and remove a link on the board. So basically that link is like a an IC which has just got links across it, so that's been removed. And then there's a little pod you connect up from the signature analyzer, and that's that there, and that connects up to a few other test points. And what we do then is we go around and just check all the all the points. Now I've done this side of the board, and all of these points were correct. Now I've done all the black figures. I haven't done the red because it says refer to the manual. It's not. It's a bit ambiguous what I'm supposed to do on the red. I'm not sure if I'm supposed to just carry on and measure all those, or what I'm supposed to do. But all the black figures are correct. So what I'm going to start doing now is I'm going to go over to the other side of the same board, but it's just side B, and it's checking. This is checking for system ROMs. So this will be the interesting bit, if the system ROMs are up the duff. Now I don't know if this is the problem. I don't know if this is the actual board that's causing the problem, but certainly going through and sort of checking everything, I can start to eliminate boards. So once I can clear all these checks out of the way and all those checks out of the way, I can safely say that that board's good, and I can move on to the next one. Because I've got these other boards coming from the States, but I don't want to just gunshot them and change the whole lot. And if I'm lucky, I can actually narrow it down to a particular IC and replace that IC. And if I could do that, which I'd be happy with, rather do that than swap a board out. And maybe we can get the display up and working. But that's a long way off yet. So what I've got to do, first of all, I've got to check, I've got to connect up all these test points. So I removed the link. This is the side B, so I've got to go through all this again. Ground, test point 5 and test point 8. There's 8, there's 5. There's the black lead, goes back to the chassis, so that's grounded. I remove jumper from test point 3 to test point 6. Test point 3 to test point 6. Did I have a jumper test point 3 to test point 6? Where is test point 3? And okay, yeah, test point 3 and test point 6 are these two jumpers here, and they're the ones that enable the ROM. So that's been removed. So basically, it's the exactly same setup as the other page, but with that link removed. And then signature, the positive, the clock signal on this box, which is the yellow wire, should go to test point 4. It does. The start signal should go to, I think, test point 11. It does. Stop signals test point 11 as well, which is this jumper here. These clips don't stay on. I think they've been used a few times, and they're like these little mini grabber things, and they're not as good as they probably once were. Come on. Okay. And then pod ground to test point 1. Pod ground test point 1, that's correct, and the probe ground to test point 1 as well, which is the same point. Now this is the probe. This is basically a logic probe. It's got this little red LED in here, and it gives you a clue of what the state's in. If it's red, I think it means there's no. That means that signal's high. I think when it's one of those. It's got 3 states. It's got dim, bright, and off, I think it has, and it sort of gives you an idea of what state it is. I need to check that in the manual, but as long as I get a decent sort of sensible figure up on here, it won't be a problem. It's got a warning up here of unstable signature, which basically means it's not absolutely sure if the signal's reliable or not. So at that point, if you've got an unstable signature, you take it with a pinch of salt. But I must admit, so far all the results have been very good. So what I need to do is enable the power supply on the spectrum analyzer. Now I'm not enabling the HV or any drive on the CRT. We don't need any CRT on, so that keeps the HV fairly safe. So I'm going to power the unit up via the interlock, so you won't get any display. You see you're already picking up interference from things because I haven't got the ground connected. So I'm going to go through these points here, and I need to be checking to see if I can get all these figures are the same. Now I expect they probably will be fine. I've got a funny feeling it might not be this board, but we'll go through and we'll do it all. I'm just checking to make sure. Yeah, see, it does. It says a self tester check, test A check. And then it's test B check in brackets B. I don't know what the difference. What's the difference? You know. So I'm going to start going through, and I assume I'm doing test A, am I? This is the wires indicated. Connect signature and pole ground leads to convenient ground, and make sure the hole and self checks are out. They are on the analyzer. Press A3A7 switch after completing connections for each of the tests. Okay. Refer to figure 8.1 to explanation of the instructions for using signature analyst diagrams. Alright, so basically I'm going to start going through. I press the system reset switch, which is on the A3A7 board, which basically restarts the system. I can't even see them. Come on. Right. So let's go through and have a look. So A4, the U4 chip is the first one. The U4 is this one here, and it's the first pin here, and this should read 3976. Unstable signature. Now, why are we getting an unstable signature? On the right ground. Let's move the this is ground this and see if we get. Try it again. We've got a ground in the wrong place. Ground's to test point 4. No, ground to test point what? Test point 1, that should be on. I'm on the wrong test point. That's my fault. That should be there. I've got to go through this again. Right, continuing on, despite the first chip seems to be a problem, let me go through the rest of the ROMs. It looks like I haven't done anything wrong with the setup. This second part of the test looks like a totally different test altogether. It's not very clear in the manual either what that is. I don't know if you just carry on, finish that test, then you go into this test. But anyway, I'm going to carry on with what I'm doing. I'm going to read these out as I go along and tell you what they should be, and then we'll see what we get. So we'll start again. We'll start from scratch with that first chip. So this is pin 1 of U4. I've moved some of the jumpers out of the way so I can get to it now. Okay, that should be 3976. Next one should be 4A46, that's correct. Next one should be A1C1, that's wrong. This is pin 4. Okay, don't check pin. Yes, I do. Pin 4 should be CBOU. 2, 3, 4. It's not. Going on to the other side of the chip, U4. Miss one, so it's A1CH. Yep. 43P7. Nope. B. It's 8U98. Where are we? Pin 1. Nope. And pin 5 should be PC2C. So 2, 3, 4, 5. So that's wrong. All those, well, not all of them. 80% of the figures on U4 are incorrect. So this is, funny enough, this is one that's got the writing on it. I don't know if you can see here with the camera, but it's got writing on it saying U4. Now I don't know if that's because the chip's blown up before. It's a bit suspicious that it possibly has. So going on to U6. Now U6, the first pin should be 3H81. Nope. Pin 2 should be 5807. Nope. Pin 3 should be 1F65. Nope. And pin 4 should be U450. Nah, that's not working either. Okay, so move on to U9, which is here. And this is another one that looks like it's been changed. It's had writing on it. 78F7. Now I'm going to press the reset button again on the back just to see if that does anything. But on the last test, I certainly didn't have to press it each time I did anything. I lost the bloody connection again. So let's go back to U9 a minute. Just press the reset button if I can get to it. So U9 pin 1, this should be 78F7. Reset. There. Not making any difference at all. Alright. Next one down. That's wrong. 085H. Oh, that was right. That's one, I suppose. Other side, this should be 8AH9. No. There's something. I think I'm going to stop here because there's obviously something wrong with this board. Let's turn the power off so I can. It's clearly something wrong with that board. Every check I've come across on these ROMs is incorrect. And someone has also mentioned before that it looks like the video ROM is buggered. And if that's the case, it's going to be a replacement board. I'm going to try and track these chips down, but I think they're programmed by Hewlett-Packard, so I think it's going to be a board swap out after that. There's no way of obviously getting the data off these ROMs, and so it's another board, to be honest with you. Anyway, that's a demonstration of the signature analyzer, and it's great. It certainly works much better than looking at logic and trying to work out what the display should read. You know, when you've got lots of ups and downs and try and work out that into hexadecimal or binary or whatever it is. So, great piece of equipment. If you are working with Hewlett-Packard equipment of this vintage, they do recommend that you use it. I know that the 4261 LCR meter I have, I don't know if you've seen my video on, so also had lots of problems with the boards. They were recommending using one of these as well to check that. But so it looks like this board. It looks like possibly the 3 ROM chips, or maybe more than 3 of the ROM chips are blown up, and we'll wait for this board to turn up, and hopefully that will fix it. Thanks for watching.